Just like how equivalents are the number of moles of charge, osmoles are the number of moles of particles that result when a compound is dissolved into solution. Sometimes it's important to understand how many particles are in solution, because the number of particles in the solution determines its osmotic pressure. When you dissolve a covalent compound in solution, like glucose, for example, if you dissolve 1 mole of glucose into solution, you will get 1 mole of particles in solution. And so 1 mole equals 1 osmole in that situation. With salts, though, they are a network of ions that form a crystal lattice, and so salts dissociate into their individual ions when they're dissolved in solution. You can predict how many osmoles will result from dissolving a mole of salt by just counting up the number of ions in the salt's empirical formula. For example, because 1 mole of sodium chloride is going to dissociate into 1 mole of sodium and 1 mole of chloride ions, it's going to provide 2 moles of particles, and that's the same as 2 osmoles for every mole of salt that's dissolved. This value, the number of osmoles per mole, is the conversion factor we use in calculations. To provide another example, if we want to determine the number of osmoles per mole of a different salt, like potassium carbonate, we would first derive its empirical formula by noting the charges on the ions. So we get the +1 for potassium, -2 for carbonate. And we crisscross these superscripts to get the subscripts for the salt. So in solution, the salt is going to break up into its individual ions. That means we'll get 2 potassium ions, and we'll get 1 carbonate ion. This will give 3 moles of particles, or 3 osmoles. Per mole of salt that's put into solution. Note that we didn't break up the salt into individual atoms. We only broke it up into its ions. So a shorthand way of determining osmoles per mole is to add up the subscripts on each of the ions in the empirical formula of the salt. So 2 + 1 equals 3. Or 1 + 1 equals 2. Calculations involving grams, equivalents, and osmoles often involve simply converting one unit into another. And this slide shows the relationships between these units. Notice that the central unit is moles, and all the conversion factors we derive have moles in common: grams per mole from the molecular weight, equivalents per mole, and osmoles per mole. This tells you that the first step in any unit conversion is going to be to find the number of moles. The second step is going to be to convert the moles that you find into your desired unit. This slide is to remind you that there is always a 1,000 to 1 relationship between milli-units and the base unit, as in 1,000 milligrams per 1 gram. And it's also true for 1,000 milliosmoles per 1 osmole, or 1,000 equivalents, or 1,000 millimoles per one of their base units. The same is also true of the relationship between micromoles and millimoles, micrograms and milligrams. Any micro units and milli units, there's a 1,000 to 1 relationship. This slide shows the different kinds of concentration expressions that you can make from moles, equivalents, and osmoles. Moles per liter is called molarity, equivalents per liter is normality, and osmoles per liter is osmolarity. And sometimes problems will specify deviations from the base values, like for example asking for osmolarity in milliosmoles per liter, and so watch for that. The molality expressions on this side of the slide are for your information only. These units are not used frequently, and I don't plan to assess on them. This slide shows a table of common IV solutions with abbreviations and percent strengths of the components. You'll be expected to know the percent concentrations of the ingredients of an IV solution if you're given its abbreviation in a problem. Fortunately, these are relatively straightforward to remember. Like for example, NS for normal saline, it refers to a sodium chloride solution at a concentration of 0.9% weight per volume. If you have 1/2 of NS, then it's 1/2 the concentration, 0.45%. D stands for dextrose, and in each of these abbreviations, if there's a 5, it refers to 5% dextrose, 10 refers to 10% dextrose, and so on and so forth. For lactated ringers, you don't need to memorize the components or their concentrations. And so on to some example calculations involving osmoles. The first one is how many osmoles per mole are provided by sodium sulfate. So sodium has a charge of 1, sulfate has a charge of -2. You can crisscross to get the subscripts. So 2 sodiums, 1 sulfate, and then we can just add those together to get the osmoles per mole, which is shown here. What's the osmolarity in milliosmoles per liter? So we did have a change in unit there of a solution made by dissolving 250 milligrams sodium sulfate in enough water to make 500 milliliters solution. So the goal here is to convert milligrams into milliosmoles and to convert milliliters into liters. So in order to do that, the first step will be to go from milligrams to millimoles. Millimoles is the center point, and that's the conversion. That's the unit that all conversion factors have in common, is moles or millimoles. So we want to know how many millimoles are provided by 250 milligrams. And to do that, we'll use the molecular weight of the salt. There are 2 sodiums, 2 times 23, and there's 1 sulfate, 1 times 96. So that gives 142 grams per mole, or 142 milligrams per millimole. You can crisscross and divide by 142. You get 1.76 millimoles. And we calculated the osmoles per mole, which is the same as milliosmoles per millimole. So 3 milliosmoles per millimole is equal to how many milliosmoles in 1.76 millimoles? Crisscross, X is 5.3 milliosmoles. So now we have that one covered. The 500 milliliters is going to be 0.5 liters. And so we have 5.3 divided by 0.5. That's 10.6 milliosmoles per liter. Last example is what's the concentration of milliequivalents per liter in the solution above. So I guess if we take our answer, we can pretty easily convert that from milliosmoles to milliequivalents to satisfy this problem. So let's see how we do that. We have 10.6 milliosmoles, and so we can go to millimoles first. So how many millimoles in 10.6 milliosmoles if there's 3 milliosmoles per 1 millimole. Crisscross, 3.53 millimoles. And then we'd use the conversion factor 2 to 1, 2 milliequivalents per 1 millimole. Why is that? So let's write this out. There's 1 sulfate, 2 sodiums in the salt. Sodium has a charge of 1, sulfate has a charge of 2. We could pick either one, multiply the subscript times the superscript, and get 2 equivalents per mole. And so that's where this comes from. 2 equivalents per mole, or 2 milliequivalents per millimole. And then we can ask how many milliequivalents in the 3.53 millimoles. Crisscross answer is 7.1 milliequivalents. So 7.1 milliequivalents is the same as 10.6 milliosmoles, and so we can just put that over 1 liter.